All right. All right, so that'd be 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. Now, guys, remember, your index or root, will tell you how many needs to be in every each pair. Okay, so we need 6 in order for them to be circled and come out of underneath the radical. They got to be 6 in each group. Well, you've got 1, 2, 3, 4, 5, 6 twos. You got 6 twos, so I can bring one of those out. Okay. Now leftovers are 3, so we will have something underneath the radical, so we do need to make our radical there. Be 3, 6. Now the 2 is going to come on the outside. RJ, come up here and see it, man. You're just talking. That mouth doesn't move. Just move up here. Don't back talk me. Yeah, I'm gonna You say number 9. All right. Do y'all need to see do y'all need to see number 3? Uh, 3 is just like number 1. Nah, let's just do 5. Okay. Because 5, 7, and 9 are all different. All right, so number 5 is 2 square root of 12 minus 3 square root of 3 minus 2 square root of 2. All right. Okay, so none of our radicans are the same. Okay, so that being said, nothing will combine right now. The only thing that can be broken down is the 12. So we'll break it down real quick. So it'll be 2 and 6, 2 and 3. All right. Now, I have a pair of 2s. I'm going to bring one of those out. Okay. Now, the 2 that we bring out, we're going to multiply it by the 2 that's already there. Okay. So that's going to be 4 square root of 3 because that's what's left over. Okay. 3 is what's left over. Okay. Now, minus 3 square root of 3 minus 2 square root of 2. Okay. Now, remember, you don't do anything with the radicals. All you do is add or subtract the outside numbers. Okay? So now 4 minus 3 is 1 minus 2 square root of 2. Guys, those are not the same. They cannot be broken down. So this is your answer. Does anybody want me to show them how to check these in the calculator? I think it'd be a good idea. All right. Now, so guys, what you need to do, because guys, what you're going to get is a decimal number. What you're going to get is a decimal number. So it's all right, so 2 square root of 12 minus 3 square root of 3 minus 2 square root of 2. Okay, if I'm press enter, there's my decimal number. Okay, there's my decimal answer. Now let's put this in and see if it's the same. Okay, so now 1 square root of 3 is the same as square root of 3. You don't have to put the 1 there. Those are exactly the same. So, guys, that's a good indication that this is the correct answer. Okay? So, basically, you put the original in, get a decimal number, put your answer in, get a decimal number. If the decimals match, then you have the correct answer. Okay? I wouldn't do that on this paper. I would do it on the test. I wouldn't really. I mean, you could practice doing it, but you don't want to. All right, number 7. Now, guys, there's a couple different ways you could do this. You could always just do, you can do inside times inside. This right here. Inside times inside and get square root of 54. Or if you want to make it easier on yourself, what's the square root of 9? 3. So it's the square root of 6 times 3. Okay? So your answer would just simply be 3 square root of 6. Now, for problems that can't be done like that, guys, don't forget when you multiply, it's inside times inside, outside times outside, and simplify if possible. It wouldn't be full credit. All right, now, so basically, guys, when you multiply radicals, you multiply inside times inside, outside times outside, and then simplify if possible. Okay. Okay, that's a good question. Um, outside is any number that's not underneath the radical. Okay. Any number, don't matter if it's a coefficient or just a constant. And the inside is what's underneath the radical. So in order to be inside, it's got to be underneath the radical. For instance, square root of 6 is inside. Square root of 9 is inside. Okay. This 3 right here, that's outside because it's not underneath the radical. Okay. All right. Anybody have any questions? Okay. Um, let's look at number 9 real quick. What's up? Yeah. Yeah. Just go to the bathroom. You are. Okay. Guys, looking at this now, if you know your perfect squares, both of these numbers are perfect squares. Okay. So, um, so if you separate these for a second, all right. Well, that becomes 2/5 times what's the square root of 4? 2. What's square root of 64? 8. So now 2 times 2 is 4. 5 times 8 is 40. Okay. All right. Now, if you reduce this, that reduces to 1/10. Does everybody understand how I did that? What y'all think? All right. Guys, let's do just to see one like it. Let's do one like number 10, even though it's an odd even one. Let's go ahead and do it so we can see one that's not a perfect square. Okay. All right. Now, guys, we know that 5 is not a perfect square. Okay. But however, square root of 9 is. Okay. So what that's going to be is this. That's going to be square root of 5, and it's going to be 4. What's square root of 9? 3. That is the square root of 5 over 12. Now, guys, just be aware that that if let's say if this right here could simplify, make sure you simplify it all the way. I've got one on the video where you had to simplify the top and the bottom. If you watch it, it should clear up a lot of misconceptions. Okay, but that would be your final answer there. Guys, what if you had this? Now, this is a example not on the paper. Say if you got it all the way down and you had this 2 square root of 6 over 20. Say you had that right there as an answer. Is that full credit? No, because what needs to be done here? The outside numbers, right? The outside numbers, 2 over 20 needs to be simplified. So that would be the square root of 6. You can put a 1 there if you want to. 2 over 20 reduces to 1 over 10. That would be full credit. Or square root of 6 over 10. Either one of those would work. Okay? What if you had this? You got an answer of, I don't know, square root of 24 over 10. Is this full credit? No, because why? Can this be simplified? It can be. All right, so now what you would do, you'd take 24, break it down, be 2 and 12, 2 and 6, 2 and 3. Okay? Now, I've got a pair of 2's here. Okay, now I got a 2 and a 3 without a pair. So what that would end up being is the 2 will go on the outside. 2 times 3 would go on the inside, which would be 6 and 10. Now, is this full credit? No, because this right here needs to be simplified. All right, now, so that's going to be the square root of 6 over 5, or 1/5 square root of 6. Yep. It ain't hard. I mean, it's not too very hard. All right, now 12 and 13. Excuse me. 11, or these are the very easy ones, guys. What you're doing, you're writing an exponential form. Okay, you're going from radical to exponential. Now remember, if it's in radical form, this is what it looks like. Better not put that right there. People think you divide something. Remember, underneath your radical is your base or your radicand. Okay, your base or your radical. And then right here, the little number here is your root. And then the little number here is your power. All right. All right, now, so to write it in exponential form, say for number 11, you've got the 5th root of 2v cubed. Yo. I don't care. All right, now, so guys, what you're going to do here, you're going to switch it up to base, and then you're going to have an exponent of power over root. Okay? So, guys, here's my base, so 2v. My power's 3. My root is 5. Okay. All right. That's how you. So, guys, basically, you're not really doing any math. You're just writing it in a different form. Okay. That's all you're doing. Guys, now on these, there's no really partial credit. I mean, it's either right or wrong. Just make sure you put your power over your root as far as your exponent goes. Okay. Make sure you put your base in the right place. Now, guys, this one's a little bit. This I think is a little different than we've done before, but it's not very hard. Okay. Now, you've got a power here and a power here. Okay. Got a power here and a power here. Now, what you're going to do here is you need to multiply those. So that's going to be 5m to the 2/3 power. Because what's 2 times 1/3? 2/3, right? All right, now, and then write it. So it's going to be this. 5m, and then my power's 2, my root is 3. That'd be your answer. So, guys, all you're going to do if you have one like this that's got 2 powers, you're going to multiply those, make it one single power, okay, and then put it in yes. All right, now we got the square root of 2b plus 22 equals the square root of negative 2 minus 2b. Okay? Now, what's our ultimate goal here in this problem, guys? We had to get it right, correct. But what are we solving for? The value of b. That's what we're solving for. Okay? Now, if we notice, guys, both of our b's are underneath radicals. How do I get rid of a radical? Square, right? You're going to square both sides. Okay? I'm going to square both sides. That gives me 2b plus 22 equals negative 2 minus 2b. Notice all you're left with is two expressions, okay? The two expressions underneath the radical. Then very simple. See, I'm going to subtract 2b from both sides. I'm going to add 2 to both sides. Okay? So what that ends up being is that cancels out, that cancels out. That ends up being 24 equals negative 4b. What was that? What was that, Jackson? Mm, well, we had to add a 2, and then to get this 2b away, I had to subtract it. If you'd have went this way, you could have done that. Yes. Yep. Yeah. If you went the other way, you could. All right. Now, divide by negative 4. That's b equals negative 6. Does everybody know how to plug it in and see if it's right? Okay, I don't have a whole lot of room. I'm gonna. If you're not sure how to do it, guys, look on the video I posted yesterday. Just fast forward; it'll show you how to do it. Because there might be an extraneous solution on some of these. All right, 17. Now, guys, what this one's going to be, this one's going to turn into a quadratic equation. I'll show you why. Because it's b equals Josh. Shh. All right. Now, guys, do I have to go through this and solve it by hand? How can I solve this? On the calculator. Y'all want to do it with the calculator? Okay, here we go. So, save you a lot of time. Okay. And it's always the same. If you ever notice, guys, intersection usually takes care of about all your stuff. So that's y1. That's y2. Okay. So now, to clear this out, That's X. Let's see. No. Put it in this order. All right. X and Y1 and the square root of negative 30 plus 13x. All right, so I got x, b. We can use the only thing we have is x. We just use x and y1, and now put my radical equation in there, or radical expression in y2. Okay, we're going to graph that. Now, looking at this calculator, how many solutions are you going to have? You're going to have two, right? Because here's one and here's one. Okay, so now where they intersect is your answer. So second trace, intersect. Guys, if you notice, intersect does a lot of things. Let's see. All right, so one of my answers is 3. Okay, and second trace, intersect again. Enter, enter, enter. My other one is 10. Now, guys, let me ask you a question. Do I have to worry about extraneous solutions here? Do I have to worry about extraneous solutions, ones that don't work, if I do it with the calculator? No, you don't have to. Huh. Extraneous. That's what it's called in math. If you it's on your paper, extraneous. No, you don't have to look, guys, because if it intersects, it is a solution. So I had two intersections here, so I will not have extraneous solutions. Now, if you've got a quadratic with one intersection, then yes, you would have an extraneous solution. Okay. All right, guys. So if we graph this, guys, I'm not going to be too picky about the graphs as long as it looks like a square root function, and you did halfway credit. Effort on doing it. I'm not going to really ding you that much. Okay. Where I will ding you is domain and range. Okay. Now, so I'm graphing the square root of x. There I am. All right, now, if I was you guys to graph this thing, I'd go to my table. So 0, 0, 1, 1. So there's 2 points right there. I wouldn't try to graph any decimals if I didn't have to. 4, 2. And 9, 3. I think that's too far. Which I'd be probably roughly about here on 8. So that's roughly about what your sketch is going to look like. Okay. Now, state the domain and range. Well, your domain, all you got to do, whatever's underneath the radical. What's underneath this radical, guys? Just x, right? You're going to set it greater than, equal to 0. Well, is there going to ever be a time when this is going to be different? Nope. It will always be x values greater than, equal to 0. Now, on your range, there can be a difference. Guys, now remember, the general form or standard form of a radical equation is y equals a square root of x minus h plus k. Looks a lot like the vertex form of a quadratic. Now, do I have a k value on this one? I don't have a constant out here. Outside here, so I don't have a k value. If there's no k value, guys, this thing opens up. Notice it's going up from left to right. So that's going to be my range. Is going to be y values greater than, equal to 0. Now, what would make this sign change? If you had a negative out here, if you had a negative out front, that would change that to less than equal to, but 9 out of 10 times, guys, that's not going to happen on here. Okay? Okay, guys, what I'm going to do, I'm going to take this as a completion and accuracy grade. I'm going to go print the key off. When you get done with 2 through 20, I want you to bring it to me and let me check it. Okay? I'm going to go print the key off. All right? You've got all these examples. All right? And I'm going to check for correctness on 2 through 20 to evens. Okay? All right.